Hello and welcome to a discussion of Module 4, Apache Spark. And I'll go ahead and go through this. We've pretty well covered all of the material so far in this course, but I'm going to circle back to this because this is where you're at. So it's one of the interesting aspects of having a course with a single student is it's very customized content. And so since you've knocked out the Hive project, then I'll move on and go back and talk about Spark, even though we've talked about it before. So jumping straight in, what is it about? As I mentioned last time I talked about this, there's a bit of a confusion in how the nomenclature is presented in this module. There is Apache Spark, that is a thing. It is a top-level project of the Apache Foundation, Spark is, and Scala is a language that is supported by Spark, and in fact the original implementations of Spark were written in Scala. But the two things are not necessarily a thing, right? So Apache Scala Spark is not really a thing. If anything, it would be Apache Spark Scala, a language that is customized inside of Spark for Spark and so on. But anyway, without digressing too much, the things that you need to know is Scala is a thing, Apache Spark is a thing, two distinct things that happen to go well together, as do some other languages such as Python, R, and SQL. Spark supports all of those. So at the end of this, you'll be able to talk about the concepts related to functional programming. And all that means is that rather than saying explicitly how something is done, you talk about what you want to get done. So what is the declarative nature of the instructions that you're doing? And then the optimizers and compilers and such inside of Spark figure out what it is that you're trying to do and figures out a nice way to do it with the highest level of performance. Filtering, nothing more than a where clause or a filter clause. They're kind of basically the same inside of Spark. So the idea is that you may want to restrict your subset just as you do with a where clause in SQL. So those are the main concepts. So what's Apache Spark? Fair question, always a good question. And the marketing sort of answer is it's a unified big data platform that's optimized for processing. And it is roughly 100 times faster than Hadoop's MapReduce in certain circumstances, such as when things can be kept in memory. And that is the reason why it is much faster, is that Spark is highly optimized for iterative development, iterative programming, iterative operations that can be held in memory by the cluster. If it starts spilling to disk, things get slower. It's still faster than Hadoop MapReduce, but maybe by a factor of 10, not 100. It's used for a lot of stuff, including analytics, data processing, and wrangling of creating data pipelines to either ingest or refine data being stored in something like a data lake. It's also used in stream processing. That's what the unified bit of it is that it does both batch and streaming in a single implementation using a very similar sort of construct. The foundation of why it works in the very beginning of Spark, there was this concept of a resilient distributed data set. They're still there. They're under the covers. You don't typically use them directly, but they are what made Spark work and still does. The basic idea is that the resilient bit is that if something happens across the cluster, and that's what the distributed bit's about, there's a cluster that these things are running across. If one of the nodes were to go down, it's possible for the driver to basically instruct another node to pick up whatever work it was that the driver, the node that went down was doing, and essentially redo everything it had done and produce the output and send it to somewhere for storage. So that enabled fault tolerance and also the distributed processing in such a way that it's very resilient to failures. The basic concept of Spark in general is it's about transformation. So you take one data frame, data set, or RDD, you outline a set of operations, and then at the point that those are actually realized, meaning they actually occur, you create another data frame or RDD from the original when it's needed. And that's the hint of the lazy evaluation. So basically, lazy evaluation, you say what all you want to get done. It doesn't actually happen until something is invoked that makes it come to be. For example, you may define a whole series of operations you want to occur within a data frame, but up until the point you say display it or show it or count it, you haven't really done anything. And that's why it'll be sub-second for each one of those operations, because nothing's really occurring just yet. Sorry about that. So the RDDs are typically in memory. Data frames, data sets are as well. They can be persisted to disk. That storage to disk slows things down, but it enables essentially unbounded workloads to be processed. So another key concept is SparkQL or SparkSQL. It's a variant of SQL, very similar to MySQL in flavor, that enables you to write essentially Spark jobs using SQL. And you do so by defining what it is you want to do. In this case, we're selecting star from people. You can also do more complex things such as group bys, wheres, and windowing operations, all kinds of fun stuff. Also notice there that the other three languages, Java, Python, and R, are presented. Generally speaking, you're going to be writing in either Scala, Python, or R. That's kind of the ones that are most typically used. You can do Java. It's not a common occurrence. And you also, yeah, Scala is there. That's what we were looking at. So another key concept is Spark structured streaming. This was introduced with like Spark 2.0 and greater. There was a Spark streaming before that it's deprecated, no longer used. Spark structured streaming uses micro batches to perform your operations. You basically do things where you view things as essentially being an unbounded table that continually has things coming in. You do some operations to them and typically write them somewhere. That's the typical sort of processing. So you read from a stream, do some sort of either transformations, enrichment, filtering, or something, and then you either write it out to a file, another stream, a table, or somewhere. So you get this idea of readers and writers in the mix. The way that it works is that there's an interval where things are getting triggered. It may be every second, it may be every minute, or some amount of time. They retrieve data at each one of those, does some work, and produces some output. The type of output, it depends upon the type of mode that it's in. You have different types of modes for your output. The complete mode is going to do pretty much everything that it's seen before. You also have a pen mode and a few other things. There's the bottom or the right side of that screenshot is essentially showing you a kind of a simple sort of counting operation, counting things as they come in. Another concept that comes up in this module and subsequent ones is MLlib, which is Spark Machine Learning Library. So that's basically, as the name implies, it's a set of machine learning algorithms that are meant to enable distributed processing of those workloads. So you have the basic ideas of doing things like classification, extraction, regression, clustering, and so on, and are supported using a construct of a pipeline. And ML pipelines are very familiar if you've done much with some sort of either deep learning type stuff or frameworks like TensorFlow. It's a common pattern to where you essentially outline a series of operations that you want to occur in the order you want them to occur and what they are and what the parameters are and all that good stuff. And then you invoke it in mass so that it then doing something like creating a pipeline and adding a few things to it and then running it. It's not necessarily on this screen, but it is something that is used quite frequently. You can also do things with graphs using graph frames and GraphX. GraphX being the algorithms, graph frames being kind of the construct that's used to store that stuff. The basic idea is that whenever you're creating a graph frame, you essentially pass in two data frames, one containing nodes, one containing edges, or vertices and edges, pick your terminology, same basic thing, that represents a mathematical graph on which you oftentimes will want to do some sort of graph processing, such as maybe traveling salesman or the page rank or looking for patterns inside of it. So with that, we'll shift over and do a demo in Community Edition. Bear with me one moment while I open up. The right notebook. And as I mentioned before, Databricks Community Edition is nothing more than kind of a gateway version of Databricks, right? The intent is to show your average person how to get started with Databricks, Databricks being a company created by the founders of Spark with the intent of bringing Spark to the world in a cloud-hosted fashion. To that end, they created this Databricks Community Edition, which has a limited set of functionality compared to some environments. For example, you're limited to a subset of operations that you might can do in the full versions of Databricks, and also you're limited in the size of the cluster that can be created. So I'll go ahead and delete this so that it makes life a little easier later on. So whenever we you can only have one cluster, and that cluster will have a single node. That single node is working both as a driver and a worker. That's the architecture of Spark. Is you have one node that is essentially the coordinator, the manager of all the other nodes. Its job is to tell them literally what to do and what to do it on, whereas the worker nodes do, like the name implies, and work on the particular elements. One moment. Sorry about that. So moving back, one of the things that you can do with Databricks is ingest data very easily. I'll go ahead and see if I can do something to get a cluster up and running. This should do it. So just working through kind of the nature of what is Databricks Community Edition. So you can go ahead and get rid of the little upgrade flag at the top, because what it's doing is trying to sell you. You can always start off with the tutorial, the quick start, right? So this is basically Databricks in 5 minutes, as the name implies. So you start off by, on the sidebar, click the compute, click create cluster, and pick a particular version of Spark is what they're saying to do. This is in the process of spinning up a cluster right now. It happens to be similar to that version. The 7.3, I believe, is a bit old compared to the current version. So Databricks cluster or Databricks versions are nothing more than kind of a definition of a combination of open source projects. So Databricks basically is obviously basing a lot of its work on Spark, but there's some other things that are in the mix as well. And so the combination of all those different versions of things, such as you can see, it's Spark 3.0.1 with Scala 2.12 or 2.12. So there's different combinations of that plus some other stuff that makes up particular versions of Databricks, including some additional libraries such as Delta, which is a layer that goes on top of a data lake, and so on. So lots of different versions. So what we're looking at here on this quick start notebook is a notebook. It's 2 or 3 things to notice. First thing, upper left-hand corner here is the name of the notebook, right? In this case, it's Quick Start Notebook. You can change that to anything you would like it to be. Also, SQL is the default language. That means every one of these cells starts off being assumed to be SQL. You can change this to something else if you're so inclined, so you can see the 4 languages that Databricks supports: Python, Scala, SQL, and R. Java's not listed explicitly because you have to kind of do some stuff to make that work. You have to upload a jar and so on. But the native languages are those 4. This cell is Markdown. That's what this %MD, and that's called a magic character or magic string. And the %MD says everything after %MD is going to be Markdown. It has to be the very first thing on the first line, otherwise it doesn't work. You can, whenever you're doing Markdown, you can see the pound sign here is the first level heading. The second 2 pound signs is an intermediate level, and so on. If you click this little pop out, you can see the organization. It kind of creates a little table of contents for you, which makes it useful if you want to work through that. So our cluster is still in the process of being created. We can go ahead and try to connect to the one that's spinning up. It's oh, it looks like it may be up and running. What does that say? So that's an old version of the runtime. Really probably should be on something more recent. To do that, if we're so inclined, you click on the cluster itself, go into edit, and you can switch to, you can see they're much more recent. LTS is long-term support, so 7.3 LTS is at pretty much end of life. The latest version that is LTS is 9.1, so probably a pretty good idea. What the LTS means is, first of all, it's thought to be good enough that you're not likely to need to make any changes to it. And it also means that they'll be offering, they being Databricks, will be offering long-term support for it. So you don't get the, well, it's out of support sort of conversation in that scenario. Also on this screen, while we're here, you do have the ability to look at where the particular node is being spun up. This is in the West, US West 2A. You can kind of tell from that this is inside of AWS. It's not inside of Azure. You can also have some Spark config values that you can set. So in this case, delta.preview is enabled. So you can do things there and also do other settings. If for some reason you wanted to connect to this cluster from a client, you can do so using the JDBC or ODBC connection. They give you the JDBC URL. You have to figure out the ODBC one yourself. It's not the end of the world. It's not unimaginably hard to figure out, but it takes a little bit of time. The permissions are also something that can be set depending upon the environment you're in. It's not available in the community edition, but you can control who has access to your cluster, who can connect, who can manage it, who can, start and stop it, and so on. While the cluster is up and running, you can also see what notebooks are attached to it, what libraries have been installed. In this case, none of these were installed because they probably aren't needed. The event log lets you know what happened when to the cluster. So we created it here. I made some changes to it here, and then it started back up and it's now running. The Spark UI lets you take a look at the cluster from essentially a management and a diagnostic perspective. You can do things like take a look at the execution plans that have occurred. This one hasn't got anything done, so not a whole lot to see here other than, I guess, the environment lets you know where Java home is, what version of Java is being ran, what version of Scala, and a few other properties that have been set along the way. So fairly useful. But the nice thing with it is, as you've seen, it's easy to get up and running, right? And that's the real value things like Databricks brings, is rather than you having to go through the process of installing Spark into your own virtual machine or something, in a few clicks you can have a Spark environment up and running and focus on learning things rather than figuring out how to configure things inside of a Linux environment or something. So to step through some of these cells, we're going to go ahead and attach, if it'll let me. It may not know that it's there. Sometimes there's a little weirdness if you don't start things a certain way. Try it again. There we go. All I did was refresh the browser so that it got up to date with the state of that cluster. So the commands here, because this is an SQL notebook, is in SQL. A key thing, if you do multiple instructions in the same cell, make sure you include the semicolon, otherwise it won't like it. What we're doing here is, as the statements say, we're getting rid of a table called diamonds if it happens to already exist. Then we're turning around and creating a table called diamonds that we know is a CSV file. And then you give it some options, such as where it is. This is a path to that data. And then also that there is a header, so we know the header is true. Then we could take a look at that table. So you can do a select star from and literally look at the first few cells. You can also do something like describe diamonds and see what the data types of the various columns are. because we didn't infer the schema up here, so header is true, infer schema is not, then it basically everything's a string. So if you wanted to do something like add these up, you need to convert them to an integer or something instead. And then also we can then turn around and potentially save this as a Delta file in our own location, right? So we're basically saying here, this is a variation on the first theme. So we this first one just did a read using that so and created a table pointing to it. So an external table pointing to the CSV file without doing any kind of schema and inference. What we're doing here is we're reading a CSV using the explicit spark.read.csv. You give it a path to the CSV, happens to be a set of data sets that are out there for us to use by the good people at Databricks. You tell it that there's a header, and we also tell it to infer schema. What those two things do together is say the first row, it's going to include the names of the columns. Every row after that should be looked at to try to figure out what the data type is. And the way that it'll do that is try to figure out, well, is it a double or floating point? Is it an integer? If neither of those two things are true, then it's probably a string. And there may be some other slight variations, but that's the basic idea. And so what we're doing here is reading in the CSV and then turning around and writing something out in Delta format in our local directory. And Delta, like I mentioned, is just a layer on top of a data lake. It lets you do things like have atomic writes, right? So that you don't have to worry about, I wrote part of my file out and my job died, so I've got part of my stuff written to the disk and part of it didn't. It's an all or nothing sort of proposition. At the point that you do operations against Delta, in particular things like a merge operation against a Delta table, you're guaranteed that it will either succeed or fail, no intermediate sort of steps. Also, you're able to do things like make edits to files inside of Delta, something that is not natively supported inside of a data lake. Generally speaking, you have to like read it in, change it, and write it back out to make a change versus just doing an update. So what we're doing here is creating a Delta table. That's what using Delta is doing from the files we just wrote out in a folder called /delta/diamonds, and telling that table diamonds. This looks a lot like your external table syntax inside of Hive, right? Because it's kind of what it is. And then now we can take a look at what that table looks like, diamonds, and we can also again describe it. And I could run it up here, but I'm going to copy it down below. Also notice you click these little pluses at the top or the bottom of the cell that you're interested in to introduce something new. So now notice that the data type of caret is a double. Some things are integer, but it's either integer, double, or string based upon the data types, and it figured that out. Also, the very last thing is it says number partitioning, and the reality here is we're not partitioned. Partitioning is how you increase your parallelism in something like Spark. So the basic idea is that you have a column inside of your data frame that has a relatively low cardinality, so there's not a whole bunch of different values, but yet it does provide an even distribution across all of the rows so that you have pretty much even-sized buckets that you can put stuff into. The reason that matters is that workers will be assigned based upon a partition. And so if it has to figure it out, it may get it right some of the time, it may not, and it being the Spark optimizer. If you have an explicit partition set up, then it's much easier to know how things are organized and how the work should be divided amongst the workers. A nice thing with Databricks is that it does give you a kind of simplistic visualization construct. So what we're doing here is a select statement, color and average price as price. So we're basically doing an alias from that diamonds table, and then we're doing a group by and then an order by. So group by color, order by color, and you can see the price increases evenly across the color. So that tells you that something that is a J color, which is probably approaching flawless, would cost much more than something that is not so well colored. You can switch between the two by deciding if you want it to be a grid or a bar. So you can change the visualization to switch to something else. There's lots of different ways of doing the same stuff. This is showing you Python. Since this is a SQL notebook, you have to use the %Python magic command to say this cell after the word %Python, everything after that is assumed to be Python. So all of the rules of Python apply. Very similar syntax as you'll see in some of the other languages. Well, actually we used Python up there before, but we're also reading in, looks like something intended for ggplot. And plotting it again by color. So that's pretty much what you need to do to get up and running in Databricks. Another cool thing to do is upload data. So if for some reason you have some data that you want to upload into that environment for analysis, maybe you're taking a data science languages class and you want to load Titanic. We always load Titanic, right? It's simply drag and drop onto this frame, and that brings you up onto a new table commands sort of setting. At this point, you need to give it either a directory. It'll figure out a directory for you, or put it inside of the tables folder. And you have a choice here of creating it with a UI or with a table or with a notebook. They're basically the same sort of thing, except you may want to do a notebook to kind of get more comfortable with what you do inside of Spark. This creates a Python notebook. You can see that up here at the top here where it says Python. And basically it's pointing to the file that we just uploaded. In this case, they put Titanic out in a tables folder underneath a file store. We know it's a CSV. It figured that out. We do want to infer the schema, and we do want to change the header to be, header is the first row, because we know Titanic has a header for the beginning, and we also wanted to figure out what are the various data types. And then once you've made those two minor changes, you can attach it to your cluster and run it. And it's basically going to load that file up and create a data frame that contains the contents. And we can see the contents. You can then turn around and save that as either a temporary view, which I'll do here. So I'm going to call it Titanic temp view, create it, and then I'm going to turn around and select from it. Notice the funny little ticks here. That's the thing that's on the same key as your tilde, right? So if you do shift and get your tilde, that's the same character. That's how you delineate things that might have spaces in it. And that's also true in Hive as well. So there, again, kind of some reoccurring themes. The major difference between this is a temporary view that is accessible certainly from SQL, but also other languages. What that allows you to do is cross language boundaries. So I can go from Python to SQL and use the data frame essentially that I'm using as a temporary view in a different language. You can also create a permanent table that points to that same data frame. And to do that, you have to just uncomment this line, and what you're saying here is going to save it as a Parquet format. You could also do Delta, right? You could switch that to Delta if for some reason you wanted a Delta table instead. And what that does is create a table called Titanic. And if I do %SQL and say select star from Titanic, you can see the contents of that same table. And you may want to do something like describe Titanic, and it'll show us the data types of the various columns. You also have the ability to have comments on each one of the columns, and you can't even have a comment on the entire table. You can see your tables over here underneath of data. So you can see here, whenever I created both of those, Titanic and diamonds, it shows up inside of this data tab underneath the default database, so that you can actually do some minor investigation. So I can take a look at diamonds. It'll show me the schema, same thing as you see when you do the describe. It also shows you basically a few first 1,000 records out of the table. if there are 1,000. I'm not sure that there's 1,000 in that. So with that, we've talked about pretty much what Databricks is like to get up and running, load some data into it, do some analysis, and once you've got this is one of the reasons why I kind of like having a notebook. You can do things pretty quickly that kind of come in handy, right? So select count as count, comma sex from Titanic, group by sex, and you get a quick distribution, right? That's pretty straightforward. But once it's into essentially a table or a data frame, you can do all the things with it that you can do with the language as a whole, including things like MLlib. So everything kind of resides on that concept, just as in pandas everything is in a data frame. It's the same kind of concept. The key difference is this data frame can be distributed across a cluster. You're not seeing that right here, but it is something that happens. You can also take a look at what happened with those particular operations. So now we can go back in here, take a look at the Spark UI, switch over to the SQL tab, and we can take a look at something that might have taken a little bit of time. I'm trying to see if there's anything. Nothing's very long because those are all fast, but we can take a look at the command I just ran. And we can see exactly, this is that DAG that we talk about, the directed acyclic graph, right? This is the series of things that it determined needed to be done. Starts with a scan parquet of the Titanic file, and you can actually expand and contract the amount of details you want to see. You can see this is very small. Only 891 rows. Took it 75 milliseconds to do the scan because there's only one file, so pretty small. The next thing is to go through, do a columnar to row, and then also do a hash aggregate. And again, you see how long such things take. Does an exchange, does a custom shuffle, a whole stage code gen, and then basically collects the results. So you can kind of see more details into what exactly it did. You can also go to and look at it kind of from a stages perspective. Similar sort of concept. Again, the DAG visualization. So you can see the same basic concept of shuffle reader and the whole stage code gen. And then you can also poke around and see additional stuff that happened across the timeline. So it's a very user-friendly way of getting familiar with Spark. I strongly recommend it and encourage it for your next deliverable, which, speaking of, let's switch back and talk about that here briefly. So deliverable 4. So your basic idea here is obviously we apply the rubric and you're to talk a bit about Spark and in particular why it's better than MapReduce. So write a simple script using Spark Scala. I'll also accept Python or R. You can pick your language, to list the top 20 companies and their locations contained in the Fortune 500 listing provided in the dataset below. Then you'll report your findings in a white paper. Write a convincing white paper that promotes a company's capabilities in providing clients with the best data services possible. Explain how Spark relies on RDD to work with a variety of operations across a distributed cluster. Explain how a DAG is used to monitor RDD calculations. Explain the advantages of Spark's in-memory processing capabilities over MapReduce. Provide a look at the underlying technology that provides Spark with these important capabilities. Using the script instructions in step 1, explain how easy it is to solve problems using Scala. Include the screenshots of your script and the results detailing the overall explanation of your work. Some resources. So to take a quick look here, let's see if I have that file handy. So what I would do if I were starting on this is literally Fortune 500, probably start off with this one. Create with the UI, since it's pretty easy. Pick our cluster, take a look, preview of the table. This lets you take a look at what it's going to look like. It knows that it's a CSV. We can tell, glancing at it, that the first row is a header. So we can move that up here, X, Y, and so on. So then if we say infer schema, it'll go out and try to figure out the schema, double, double, int, string, string, and so on. And then you just need to give it a good name. So maybe Fortune 500, and create the table. And notice this didn't give you the choice of just creating a temporary view. We're actually creating a real table. So the next thing I would probably do is go and create a new notebook and call it whatever, Fortune 500. And I'd probably do it in SQL if it were me. And then you start off with select star from Fortune 500 and see if we've got the right table. And then we're asked to top 20 companies and their locations. So probably the top would be based upon this rank. Select star from, I'll just copy since I'm already there, where order by rank. Let's do that, see if that's the right way. Yes, it is. Limit 20 or 20. It uses the SQL, MySQL syntax, not TSQL syntax. And then we're supposed to, and their locations. That's probably the X and Y, I would assume. Or maybe latitude and longitude. Or is it the same thing? It's the same thing. So, strictly speaking, it's X, comma, Y, comma, probably name. It doesn't really say. All right. And don't think map, maybe. All right, why don't we try some reason it's, there we go. All right, so country codes. So yeah, that's not going to work unless we just do state. It's not exactly what it's asking for, but this is for fun. Yeah, so this isn't working out. Oh, it probably wants a different name. That's why. So the map probably isn't going to cut it. But you probably could do a scatter and do X, Y name. Trying to make it bigger. Yeah, there we go. Not terribly useful, but you get the basic idea that pretty quickly you can be outputting things, and you can also do it with Scala. It's not a real hard one to write with Scala either. Back to the slide. Here's some references that are pretty good. Apache Spark with Scala. It's a pretty good one with from the Towards Data Science site, and so on. The rubric pretty much is pretty straightforward, only 3 criteria. As always, if you have questions about anything I went over, let me know. My goal is to get you through the course with as little pain as possible. So let me know what I can do to help with that. As always, stay safe, and we'll talk again on Wednesday.